Alright, so we're starting our chapter on factoring now, and today we're going to talk about factoring by the greatest common factor. So your essential question is, when can I factor out the greatest common factor of a polynomial? Well, before we get started, we're going to go over a few definitions. So a polynomial is just an expression that consists of multiple variables, coefficients. It has operations like addition and subtraction and multiplication. And also, to be a polynomial, all of the exponents in the expression have to be 0 or positive numbers. So for example, this expression here, 8x cubed minus 2x squared plus 26x minus 21, would be considered a polynomial that has 4 parts. And the prefix poly means many, so it just means that it has many parts. Now, there are different types of polynomials. One is called a monomial, which is a polynomial that just has one term. Mono means one, so something that would only have one term would be something like 2x to the fifth. What considers a term is that it is separated by a plus or minus sign. So if I was to have like plus 3, then this would have 2 parts, but it only has one part because it just has the 2x to the fifth. So that would just be a type of monomial because it has one part. A binomial then would have 2 terms. So for x plus 1, you have a plus sign here separating the 2 terms. So this would have 2 terms and be considered a binomial. A trinomial is a polynomial that has 3 terms. So we see here the subtraction symbols separate the parts, so there are 1, 2, 3 terms, which would make it a trinomial. Alright, then we have something called factors. Factors are things that can be multiplied together to equal a product. So if I multiply 6 times 3, I get 18. So 18, if I want to look for factors of 18, 6 and 3 would be considered factors of 18. So let's talk about all of the factors of 12. So what numbers can we multiply to get 12? Well, I can do 1 times 12, so 1 is. I can do 2 times 6, so 2. I can do 3 times 4, so I would have 3 and 4. And then I said 6 because I did 2 times 6. And also 12 because 1 times 12. So 1, 2, 3, 4, 6, and 12 are all considered factors of 12 because those are things that can be multiplied in order to get 12. So let's talk about factors of 4. Okay, well, I can divide 4 by 1, 2, and itself, 4. Well, the greatest common factor, otherly known as the GCF, is the largest term that can be divided out of all parts of an expression or a number. So if I wanted to find the greatest common factor of 12 and 4 together, if those were 2 things that I was looking at, then I would look, and 4 would be the greatest thing that they have in common that can be divided out of both numbers. So if we think of this as polynomials, in terms of polynomials, it says find the GCF of the following polynomial: 3x to the 6th plus 27x to the 4th minus 9x squared. So I have to ask myself the question, what is the greatest common factor of all 3 terms? So I have to look at all 3 parts. What can be the largest thing that can be divided out of all parts? If I look at the numbers 3, 27, and negative 9, what is the largest number that those can all be divided by? And I know that they can all be divided by 3, so 3 is going to come out. And if I look at the rest of the parts, I have x to the 6th, x to the 4th, and x squared. So what is the largest number of x's that can come out of all 3 parts? Well, x squared I could take out and I could at least take out 2 from the 4 of here, and I can take out 2 from the 6 of here. So x squared is going to be the most number of x's that I could take out. So 3x squared then would end up being my greatest common factor. So now let's go one step further. It says factor the following polynomials by taking out the GCF. So when it says factor, that means you have to come up with 2 things that can be multiplied together to get this product of 10x squared minus 2x minus 24. So I'm going to come up with the 2 things that multiply together to equal this by taking out the GCF. So if I look at my terms, what is the largest thing that can be divided out of all 3 parts? So if I look at my numbers, 10, negative 2, and negative 24, the largest number that can be divided by those terms is 2. And then I need to look and see if I can divide out anything else. Well, if I look at the variables, this 24 does not have a variable, so therefore I cannot take out an x or x squared or anything else from these 3 terms because the 24 doesn't have one. So 2 is my greatest common factor. Now, if I divide these by 2, I want to figure out what's left because I'm factoring, so I'm figuring out what things can I multiply together to get this product. So if I take 10x squared divided by 2, then I would get 5x squared. The x squared would still be there if you divide it by the 2. Then negative 2x divided by 2 would be negative x. And negative 24 divided by 2 would be negative 12. So my factors are 2 and 5x squared minus x minus 12. Now you can check your answer by multiplying to see if when I multiply these, I end up with this product. So if I was to distribute the 2, I would end up with 10x squared minus 2x minus 24 if I multiply all of these by 2. So I should end up with the same product at the end as what I started with. That is factoring. Factoring is going backwards. Let's try another example. We have 49b to the 7th minus 14b to the 5th plus 56b to the 4th. So we're factoring by taking out the greatest common factor. So if I look at my numbers, what is the greatest common factor that can be taken out of all 3 parts? So if I look at this, I know I can take out 7, but I need to know if that's the greatest common factor. So I'm going to go ahead and take out 7, and I'm going to see if that's the greatest one. So if I take out 7, then I have, if I divide this, oh, I'm sorry, I need to go back one step. Okay, so 7 is the greatest number that can be taken out. Then we need to look at the variables. So if I look at the variables, then b to the 4th can come out of this one. And there's at least 4 here, and there's at least 4 here. So b to the 4th can also come out. So 7b to the 4th is actually my greatest common factor. If I divide that out, then I should be able to take that out of each part and see what's left. So 49 divided by 7 is 7. And if I take b to the 7th and I take out b to the 4th, then there would be 3 b's left, because 7 take out 4 would be 3. So b to the 3rd. Then if I subtract, if I take negative 7 negative 14 divided by 7, then I would end up with negative 2. And I have b to the 5th, and I'm taking out b to the 4th, which just leaves me 1b. Because if I have 5 and I take out 4, there's 1 left. Then if I take 56 divided by 7, I get 8. And b to the 4th divided by b to the 4th would just be 1. So that would be my answer. So these would be the 2 factors that I multiply together to get this end product. And I can check it by distributing. And if I multiply, 7 times 7 would be 49. B to the fourth times b to the third would be b to the seventh. B to the fourth, or I'm sorry, 7b to the fourth times negative 2b would be negative 14. And then I have b to the fourth plus 1, so b to the fifth. And then 7b to the fourth times 8 would be positive 56b to the fourth. So it comes right back out to what I started with. Alright, one last thing and then we're finished. Multiplying binomials. So remember, a binomial is just a polynomial that has two parts. So I have one two-part binomial and another two-part binomial, and I'm going to multiply these together because the parentheses next to each other implies that we're multiplying. Now there's two different methods that I'm going to show you, and you guys can choose which one you like best for multiplying binomials. The first one is the stacked method. So if I take x minus 3 and x plus 1, and I stack them to multiply them together, then if you think about how you normally multiply, if you think about how you normally multiply numbers, okay, like for instance, if I have 21 times 16, let's go over that. Then you would take the 1 times the 6, which would be 6, and 2 times the 6, which would be 12. Then because it's two digits, we drop a 0, and then we do 1 times 1, which is 1, 1 times 2, which is 2, and then we add these together, so we get 336 as the answer. So the stacked method for multiplying binomials is very similar. You would take negative 3 times 1, which would be negative 3. Then you would take 1 times x, which would be 1x. Then we would drop a 0, just like we did over here, because it's two digits. And then we have x times negative 3, which would be negative 3x. And then we have x times x, which is x squared. You can put plus signs in between these ones that didn't have a sign if you want to. And then I would add these together. So negative 3 plus 0 is negative 3. 1x plus negative 3x would be negative 2x. And then we just have x squared. So the answer would be x squared minus 2x minus 3. So the stacked method, you just multiply like you would multiply regular numbers and just keep all the signs. You want to treat this as a negative 3, just like you would as if you were multiplying other numbers. Now the more common method that you guys might have seen before is called double distribution. This is also known as FOIL, which stands for first, outside, inside, last. I don't particularly like that acronym because people get confused on what they're supposed to do. So I teach it as double distribution, which is the same thing really. So normally when we multiply a number outside times a number inside the parentheses, that's distribution. And in this case, we have two numbers to distribute. So we're going to distribute the 2x first. So we have to take 2x times both numbers. So let's do that first. So we would have 2x times x, which would be 2x squared, because there's two x's, so you have to make sure you square it, because x times x is x squared. Then we have 2x times negative 7, which would be negative 14x. Okay, then we need to distribute the 4 to both numbers. So then 4 times x would be positive 4x, and 4 times negative 7 would be negative 28. So from here I just need to see if there's anything that I can simplify. Well, because these are like terms, I can combine these like terms in the middle. So I have 2x squared, and then negative 14x plus 4x would be negative 10x, and then I have minus 28. So this would be my final answer. So you can choose whether you like to do double distribution or stacked method, whichever is easiest for you to do. There's one last example of how to square a binomial. So remember, a binomial just has two terms, okay, and we're squaring it. Well, if you look at this problem, if you think of a number that you're squaring, like 4 squared, what does that mean that you are doing? Well, you're taking 4 times 4. So you're multiplying that however many times the exponent indicates. Okay, and then we get 16. So if I'm squaring a binomial, really I need to be rewriting this as 3x minus 5 times 3x minus 5. So then I'm just multiplying two binomials, just like I did before. So you can choose to use the stacked method or double distribution. I'm going to do double distribution. So I'm going to distribute the 3x. So I would get 9x squared, and then 3x times negative 5 would be negative 15x. Then I would distribute the negative 5. So I have negative 5 times 3x, which is negative 15x, and negative 5 times negative 5, which is positive 25. Then I can combine the like terms, and so I end up with 9x squared minus 30x plus 25. And that would be my final answer. Now, if you are done with this method, you like double distribution best, you can go ahead and stop the video and write your summary. Just make sure to answer your essential question. But I am going to show the stacked method, so if you like that better, I'll show that one more time. So if I have 3x minus 5 times 3x minus 5, and I stack it, then negative 5 times negative 5 would be positive 25. Negative 5 times 3x would be negative 15x. Then I would drop the 0. Then I have 3x times negative 5, which again is negative 15x. And then 3x times 3x, which would be 9x squared. So then we go ahead and we add together. So we have 25, negative 15x plus negative 15x would be negative 30x. And then we have 9x squared. So you notice we get the same answer. All right, thank you very much.